Go ahead and get started. Welcome to today's webinar, Prevent Leaks and Reduce Emissions, How IoT is Empowering Energy Companies to Deploy Continuous Emissions Monitoring Technology. Today's webinar is brought to you by Particle and Qube Technologies. Thank you all for joining us today. Before we get started, I want to remind you that you will receive a recording of today's webinar this afternoon, as well as a PDF copy of the presentation. If you have any questions anytime during the webinar, please click the Q&A button in your Zoom window at the bottom of your screen and type your question there. The presenters will read and answer your questions at the end of their presentation. Thank you again for joining us, and I will now turn it over to today's presenters.
Hello, my name is Sanjay Mehta. I'm Director of Product Marketing at Particle. Welcome everyone to the webinar. I want to thank everyone for being here. Today we're going to have Cyril Bernard, our Enterprise AE at Particle, along with Eric Wen, CEO of Qube Technologies, present the webinar with us. All right. So as most of you know, we are the leading edge-to-cloud platform in IoT. We provide intelligent connected devices and help enterprises bring those products to market, providing unprecedented insight into physical assets and operations. We also work with leading analysts such as IDC, Gartner, Forbes, and others, and we are placed as leaders in the IoT space. We have a great portfolio of customers from Jacuzzi to Watsco to Continental and GM. And we have the largest developer community in the world with over 300,000 individuals in our developer community worldwide. We also have 850,000 devices shipped by Particle to date, and then also 8,500 plus companies around the world that are using Particle today. Over 50% of the Fortune 500 companies use Particle in their enterprise architecture. And then we're happy to say we also have 60 billion messages managed per month by the Particle platform. So with that, I am going to turn it over to Cyril, and then I'll be back with the moderation of the questions and Q&A later. So Cyril, all to you.
Sure. Nice to meet everyone virtually. You know, when people think of IoT, and you ask around, you think about how can I unlock my front door or change the temperature of my thermostat. But what's becoming more and more prevalent and is the use of IoT in essentially addressing the challenges posed by global warming and specifically emissions management. And if you will, IoT can be really helpful in 4 key areas. The first one is around quantifying and reducing emissions. And essentially, by using sensors and connectivity, you can detect fugitive emissions as they occur, and as Eric will talk later, accurately identify where the source of emission is occurring. You can also measure air quality, which is becoming critically important as we're faced with challenges of the 21st century and issues that were really brought forward by the recent COP26 conference in Scotland. But also what's really critical is the insights that you get from the analysis can actually help you address and provide pointed data and information to actually repair those leaks and get to these repairs faster before things become more of a disaster. And I think the big elephant in the room for a lot of the oil and gas organizations probably listening to us today is how do I comply with regulations? These are becoming more and more strict and stringent. And how do I not only meet but get ahead of those kind of complicated and stringent regulations that are put in place to help curb dangerous, greenhouse effect and gases. So specific to methane detection, I'm really excited to turn things over to Eric, who's the Chief Operating Officer of one of Particle's partner, Qube. And Eric actually has partnered with us to develop a very innovative solution to help organizations detect and curb methane leaks in oil and gas industry. So Eric, if you don't mind telling the audience today, can you tell us a little bit about how Qube got started, and what sort of problem do you solve? I mean, are you providing a product, a service, a combination? So love to hear a little bit more about how you've been able to apply those IoT capabilities specific to Qube.
Yeah. Hey, thanks, Cyril. It's great to be here with everyone. Thanks for having me. So Qube got started in 2017. The story is actually kind of funny. Our founder, Tej, was a student here in Canada, and he was living with his family sitting in Canada, and his house actually backed onto an abandoned well. And he, engineer by trade, he rigged up this low sensitivity methane sensor that would send him an alarm whenever methane concentration reached a certain amount. He would tell his grandparent, hey, don't go outside, the air is not really good. He pitched this idea in a couple industry events, and long story short, he was able to get hooked up with some seed funding and some early adopters to develop what Qube is today. So we've been around since 2017, and we've been working with some of the larger operators in Canada and migrating down to the US. We help oil and gas customers primarily right now address some of the new challenges they're facing around emissions monitoring. The way we do this is through continuous monitoring, and with the advent of low-cost IoT platforms like Particle, we're able to offer continuous monitoring at a very cost-effective manner. So Qube offers both a product and a service. So the product itself is the Axon device on the left-hand side here. This is what we've developed to continuously monitor for detection events across a number of gases, including methane. That is sending that data into our cloud platform, where we actually analyze that data and we infer what is actually happening on your site. So rather than giving you part per million data over time, we can actually tell you how many leaks you have, how big each of those leaks are, and whether those leaks are vented or fugitive emissions. And all of that's kind of displayed on a web-based dashboard where you can investigate, track, and report on your emissions profile on a quantitative basis.
Got it. Thanks, Eric. And what could you tell us what makes Qube unique, right? Because there are a number of startups and players in that space, right? What makes Qube kind of different from other offers out there?
Yeah, great question. I mean, this is a pretty hot space these days, especially after COP26. We do have competitors out there. I think we're unique in a couple different ways. Firstly, we spent a lot of our efforts developing the hardware itself. That's all built in-house. We are continuously monitoring for methane emissions as well as other gases. We're basically sampling and transmitting data every 3 to 5 seconds. What we also mean by continuous monitoring is we can operate in a lot of different environmental conditions. We're a Canadian company. A lot of our early customers are based in Canada, where it can be quite cold in the winter. The same device that we deploy in northern Alberta is the same device that we put out in the Permian Basin in the heat of summer. And we've been very proud to say that we've had very little downtime because our hardware is quite robust and quite capable in a bunch of different temperature ranges and relative humidity ranges. The second piece is we've focused our design to be very, very low cost. There's a lot of different sensing technologies out there that offer potentially greater granularity and greater resolution. When we looked at the market, we wanted something that's low cost, but is accurate enough. We think it's more important to be able to detect between 2 to 3 ppm than 2.1 and 2.2 ppm. So part per billion resolution for certain gases is really nice, but for methane, especially when the background rate concentration of methane is typically around 2 ppm, we think 1 part per million resolution is important, and that's what allowed us to get to the low cost basis using metal oxide sensors. So we, for less than $100 per month per device, you can get continuous monitoring using our devices. I mentioned the multiple gases. In addition to methane, we have a modular design, so we can put in 4 other different sensors. Think of it as a menu of options: H2S, SO2, VOC, NO2, and carbon monoxide. We're working on another kind of platform for our sensing mechanism, where we're going to have CO2 as well as particulate matter. So, what we want to do for our customers is, everyone cares a lot about methane and monitoring methane, but there are a lot of other things that we want to monitor for as well. And we can do this with one device. An example would be, we work with a lot of our customers on odor management issues and dealing with nearby landowners, helping either our customers get out of odor complaints or help them proactively address those odor complaints, odor issues before they become complaints. I think lastly, we go through a pretty rigorous process for calibrating these metal oxide sensors. There's a multi-stage process in which we take them through a lab calibration and field calibration to make sure that the data that's coming out is accurate, and which we can use then to infer what's happening on a leak quantification, leak location basis.
That's great to hear. And I understand you're able to work with multiple gases, and the solution is very accurately calibrated. But I'm assuming you do a lot of testing, right? Can you kind of help us understand what that process looks like, and what do clients actually get to experience with that?
Sure. Yeah. So the way our metal oxide sensor works is we actually take it through a multi-stage calibration process. So the first step is actually in a lab calibration. We will, because these sensors are low cost and highly sensitive, they're also highly sensitive to temperature and pressure. So we actually put them in a lab chamber where we set the amount of gas at known quantities, and then we vary the temperature and relative humidity to create a compensation curve. So each sensor that we put in our device has their own individual coefficients for the curve. We've also designed a new PCB board to get the resolution that we need. The second piece, which is what you're seeing here, is we built our own control release testing facility just west of Calgary. This is where we actually kind of put our devices to the actual test, where we can release known quantities of gas and then compare it to a reference monitor in ambient real life conditions. So this is a test that we did where we pitted our Axon device next to a $150,000 Picaro gas analyzer. We're getting really good responses throughout the control release event, and we're getting correlation coefficients of over 0.9 in most cases. This is obviously a controlled environment, outdoor environment. We also take these out to the real life site. So this is a deployment we did out in the Permian, where we brought our own Los Gatos, which is a different gas analyzer, $50,000 only. And we compared it to our Qube Axon device. Obviously, very good responses, very different technologies, but through these kinds of tests, we're pretty confident that we're getting the same resolution as something that's much more expensive and typically uses a reference monitor.
Got it. And does Qube have to go through any sort of regulatory review or kind of vetting, basically by government-sponsored institutions, just to kind of make sure these are accurate and can be used as a source of the truth?
Yeah, so we are seeing a lot more increased regulations around methane. I think we started out in Canada where the federal government introduced methane reduction targets in 2020, and then the provinces have to create programs to enforce it. And, we're proud to have the only continuous monitoring technology in the world right now that has regulatory approval for use for leak detection and repair. We're currently working on other approvals in other jurisdictions, including in the US as well. But this is, we're pretty proud because this allows our operators and our customers to meet their regulatory commitments in a cost-effective manner. It also helps the regulator in the sense that we are able to give them a level of data granularity that they never had before. Before continuous monitoring, you're using OGI intermittent surveys typically, and you're only inspecting leaks 2 to 3 times per year. If you find a leak, they'll fix it. Now we're able to give customers the granularity to look at across all your sites, figure out where are your biggest leakers, and help you optimize, how to spend your repair capital most efficiently, and then also give you the data where you can actually take it to an investor or a certifier and show that you have a certain methane intensity and you can get a premium on the gas that you produce. So we're really excited about the regulatory process. We're learning a lot through the process. I do want to clarify, continuous monitoring is an important step, but ultimately what reduces emissions is actually going out and repairing leaks and upgrading equipment. The data that we actually provide, we think will help operators, pick out which of those facilities to upgrade first and which of those facilities to fix first. Because chances are most facilities are leaking. But what we found is that, it's like an 80-20 principle where 20% of your site account for 80% of your volume. If you're doing intermittent survey, it's really difficult to figure out which of those 20% you need to focus on first.
Got it. And with those approvals, where does that allow Qube to be deployed, right? Can you help us understand where your solutions are being currently used and perhaps a window into the future?
Yeah, so we've started in Canada where we've primarily been deployed with some of the larger operators, but we're slowly migrating out to the US. The picture on the left-hand side is a deployment that we're out in the Permian, and we're starting out in the East Coast as well. We just closed our Series A funding with SCF Partners and Nestor, and methane is a global problem, and we want to expand globally with our solution. We're putting a lot of our efforts right now in creating the system to help people not only manage a single site, but multiple sites. And the picture on the left-hand side is just a snapshot of the dashboard that we're creating, where you can manage emissions at an aerial and regional basis.
Got it. Thanks. So just wanted to summarize, right? So Eric and his company Qube can essentially actively do one or two of these pillars, right? I'm about to present. But essentially, when you think of IoT and what capabilities it can afford with regards to emissions control, the first big pillar, right, is around environmental sensing, right? And that's exactly what Eric is doing with Qube. He's detecting high level of gases, again, methane being the primary one, but there are other gases that you can monitor. This is very easily achieved by different type of sensors to measure different type of gases. But the other kind of capability that's pretty important about IoT is you can actually monitor the actual equipment. So in addition to detecting leaks and detecting gases, you can actually look at the device activity, pumps, gauges, hydraulic systems. These can all be monitored using different type of sensors in addition to the actual gases themselves. And then the last point, which is pretty critical, right, is God forbid there's an emergency, there's a problem, there's actually a leak in one of your pipes, in one of your machines. You can actually turn things on and off with IoT, right, which is essentially connecting the physical to the cloud. By not being physically there, you can actually automatically shut down a pump that's leaking until you bring a repair crew and potentially mitigate a very bad situation. So, in summary, if I can talk a little bit about what we've been able to achieve with Qube, right, and Particle is, we've successfully partnered with Qube and many other companies in the space, and we're able to provide a robust and flexible, essentially enabling technology that allows you and allowed Qube to rapidly develop a solution that's very customized based on your needs, and ultimately gives organization in oil and gas a competitive edge, because not everybody's using these yet. They will, but they haven't. And the big elephant in the room, right, as evidence with COP26 and the Paris Clean Air Act, is people really have to get on the train and make sure they comply and enforce some pretty strict safeguards around dangerous gas. And obviously the oil and gas industry is one of the main industry that's being named or called out on this. So with Particle and with partnership with Qubes, and many others, we hope to really continue to help and really solve this pretty important problem. So that's kind of my closing thoughts. And again, Eric, I really appreciate you telling us more about the Qube initiative and how successful you've been. We're really proud about all the work that you've done. And at this point in time, I'd like to turn it over to Sanjay to address any question the audience might have.
Great. Thanks, Cyril. Thanks, Eric. Appreciate it. We do have a few questions coming in. First question for Eric. Eric, does your data provide insights into the cause of anomalous emissions? In short, the time it takes to identify leaky assets and processes?
Yeah, so we certainly do. And I think, the value of continuous monitoring is that you can detect a leak within minutes, hours, or seconds of when it actually happens. When you compare that to intermittent OGI technology, you are only detecting when you're actually surveying out on site. So just having that continuous data stream is really important. I think if I understand the question correctly, in terms of anomalous emissions, because we're measuring things like wind speed and wind direction, we actually use that data to figure out where the leak source is coming from. We've developed some pretty cool machine learning algorithms that will look at both a constrained and unconstrained view, where in a constrained sense, you can tell the system, I have all these assets around the site perimeter, if the localization algorithm tells me it's from this area where a bunch of tanks are, I can say, okay, we've detected something, it's roughly this rate, it's coming from the tanks. We're actually also embedding some more kind of metadata that helps our machine learning algorithm identify anomalous detection. For example, if we are on a site where you have high bleed pneumatics in certain areas, we can tag those things as high bleed pneumatics. And then as our system learns that, okay, it recognizes whenever the wind's blowing this way over this certain period of time during the day, we're getting these kind of intermittent detection events from our high bleed pneumatics. Well, that's likely a vented source. Whereas in other cases, we're trying to teach the model to identify what is actually fugitive emissions as opposed to a vented emission.
Great, thank you, Eric. And actually here, another one for Eric. I see that your sensors are deployed in oil and gas fields. We're trying to use Particle's IoT modules in the same environment, but experience connectivity problems due to interference caused by oil field equipment. Did you face the same problems? And if so, how did you mitigate those, Eric?
We haven't had any issues in terms of like interference so much with other oil field equipment. The way our sensors work is we typically deploy these around the fence line, so you're not directly next to a piece of equipment. So that could be partially why we haven't experienced this issue. A lot of our like the way our sensors work is you need wind transport, and the further away you are from an asset allows the wind to actually shear any potential leak sources down to those sensors. So, we're typically between, let's say, 20 to 75 meters away from any asset. So we haven't had any experiences with interference causing connectivity issues. I think the biggest primary or connectivity issue that we've had is more to do with our own personal hardware or firmware, where sometimes we'll connect to a network, but then something will happen, we'll get stuck in a loop and we'll get reset and then kicked. If you try to connect to certain networks too many times, you actually get kicked off. But that's something on our end that we've tried to kind of manage. But the one thing that's been great about working with Particle and the boron device is LTE connectivity is only increasing for large parts of the world, and so far we haven't had any issues where we haven't been able to connect using the boron device.
Great, thank you, Eric. A question for Cyril. Cyril, how would you describe your relationship and partnership with Qube against other top competitors in the industry? And what do you two offer in addition to other competitors?
I think there's been really a close working relationship between Particle and Qube from the start. We kind of pride ourselves in being involved and proactive in helping our client design their solution. When I look at Qube and they just very successfully raised their first series of financing and are growing rapidly. I think we've had success stories with Qube, but with other early stage companies that are really led by very smart people that have a great project and a solid go-to-market strategy. So what we've done with Qube, we've done with other companies as well. What I'll say is, Particle works with small and large organizations, and we have a solid track record really of long and continued partnership. So what I see with Qube, and we've been working together for a little over a year now, or a year and a half, is that these relationships last a very long time. So the industry is growing, the products and the capabilities are growing. So it's really a pretty strategic relationship that we have. And, I really think that we can and continue to work for many, many years, right, with our partnership.
Excellent. Thank you, Cyril. Do appreciate it again, once again. Those are all the questions that we have from the audience. If there are any others, we will keep it open for about a minute. If not, we will conclude. And once again, thank you to Eric, thank you to Cyril, and thanks for everyone attending. With that, I'll hand it over to, do you have any questions, Cyril?
Yeah, no, Sanjay, I just had one question for Eric,
Sure.
which we haven't talked about. So Eric, in the course of kind of bringing a successful product to market, a solution to market, can you share with the audience maybe some lessons learned or things that maybe you weren't thinking about at the time, which became pretty important, or things that were kind of gotchas along the process?
Oh, where to start? I mean, it's interesting to try to build a hardware startup during COVID and the supply chain issues that are. But I think there's been a lot of valuable lessons learned over the past couple of years. I think two that I'll share is one, when we looked at the market about who we wanted to partner with in terms of our modem and our microcontroller unit, we wanted something that was quite simple, quite scalable. You can easily embed it into our main PCBs, but also had a lot of services to offer. So I think for us, working with Particle in your boron architecture really made a lot of sense. Right now we have thousands, or we're working towards getting thousands of devices out in the field, but the fleet management service where we can update, change firmware on the fly using over-the-air update without having to physically go to a device is a game changer for us. A lot of our deployments are in very, very remote locations that is difficult to access or time consuming to access. So having that ability to have a tool that is not only scalable and low cost, but has these kind of fleet management services been really, really valuable for us. I think the second thing, these are early days in emissions monitoring. There's a lot of new entrants in the space. You have everything from satellites, to airplanes, lasers, to fixed sensors like ours. One of the things that we've taken a lot of great pride in, and we've been very lucky with, is having a good early set of adopters, and those customers are increasing, but listening to them and really understanding what are the challenges they face and how do they approach emissions monitoring. There's not really a handbook out there, and every company kind of wants to employ different work practices. How do we create a product where we're giving them valuable data and valuable insights, but we're also not too prescriptive about you need to do a follow-up if it X or Y, and creating kind of a platform that works for everybody and that is adaptable. So that's been a valuable lesson, and something that we still relish. Most of us at Qube are engineers by background, and the majority of us have worked in oil and gas at some point. I myself was a petroleum engineer with Talisman, and had I stuck with an operator, I would have likely been an end user of a lot of these continuous emissions monitoring devices. So, listening to those customers, really truly understanding, working with them to create a solution that works for everybody is something that we take a lot of pride in.
Thanks, Eric. That's great advice and feedback. Sorry, Sanjay, I think that's all I had. Just want to.
No, great. Thanks again, Cyril. Thanks, Eric. I think we're through with the questions. So with that, we will conclude and thank everyone for attending. So everyone have a great day, and thanks again.
Thanks, everyone.
Thank you all.